Hey everyone, and welcome to The Explainer. Today, we're going to pull back the curtain on the hidden engine that powers pretty much everything in our world. It's this amazing force that shapes your life every single day in ways you probably never even think about. So, let's dive right in.
Let's kick things off with a little riddle for you. Seriously, think about it for a second. You've got food, clothes, and the unbelievable power of a rocket lifting off. I mean, they couldn't seem more different, right? But believe it or not, they are all connected by one single powerful answer.
And that answer, it's not a thing, it's a process. It's kind of like a recipe for discovery that lets us understand and then completely reshape the world around us. This method, this is the real secret that ties everything we just mentioned together.
And here it is, the scientific method. Now, you've probably heard this term thrown around, but it's hard to overstate just how important it is. It's the blueprint, right? The systematic, step-by-step approach that is the absolute foundation of all scientific research, and especially for chemistry.
So how does it work? Well, you can think of it as the journey an idea takes. It all starts with a hypothesis. That's just an initial guess, an idea. Then you get to the experiment, where you actually test that idea. If your idea holds up after a ton of testing, it gets promoted to a theory, and only when it's proven true without a single exception does it finally earn the title of a scientific law.
But you know, it's almost never a straight line to the finish. So what happens if you fail? Well, in science, failure is just data. If an experiment gives you negative results, you don't just give up. You go back, you tweak the hypothesis, or maybe you scrap it entirely and start over with a brand new one. It's this constant loop of trying, failing, and refining.
Okay, so that's the method, the big idea. But how does this abstract process actually, show up in our day-to-day lives? Let's get into our first big example, starting with something we all do every single day. Eating. I mean, just think about the sheer scale of the challenge here. How do you feed a planet with billions and billions of people? It's a massive problem that needs some pretty big solutions. And chemistry, all guided by that scientific method, has been a huge part of the answer.
The impact here is just staggering. Let's talk fertilizers for a second. The chemical process invented to create ammonia-based fertilizers, you could argue it's one of the most important discoveries of the 20th century. Today, it's responsible for feeding almost half the world's population. It's just mind-blowing. And beyond that, chemistry gives us insecticides to keep our crops safe, preservatives that let us ship food all over the globe, and even ways to enrich food with nutrients to fight malnutrition.
All right, so from our plates to our closets, it turns out chemistry has also completely revolutionized the very fabric of our lives. And I mean that quite literally. Before modern chemistry, your choices for clothes were pretty limited, right? Things like cotton, wool, silk, and they were often super expensive. But through some really intensive chemical research, a whole new world of textiles was born, designed from the ground up by chemists. This research is what gave us the very first truly man-made fibers, like nylon. It was actually created to be a substitute for silk, but it turned out to be stronger, cheaper, and way more versatile. And after that, the floodgates opened. A whole wardrobe of new materials came along, making clothing way more affordable, durable, and available to basically everyone. Okay, let's zoom out. We've seen chemistry in our kitchens and our closets, but its impact gets a whole lot bigger. It's also at the heart of immense power and discovery, from national security all the way to exploring the cosmos. Think about it. Whether we're talking about the tech needed for defense or the powerful propellants that launch rockets into space, at the end of the day, it's chemistry that's providing the fundamental force. It's the science that describes how explosive substances work, the kind of stuff that can literally change the course of history. And this is nothing new, by the way. The recipe for early gunpowder was a simple but absolutely world-changing chemical mixture. Some sulfur, some charcoal, and potassium nitrate, which you might know as saltpeter. Early chemists used that scientific process to figure out the perfect ratio to create a powerful explosion. And with that, they changed warfare forever. But of course, science never just stands still, right? The next huge leap forward in ammunition was the invention of smokeless powder. And its key ingredient was this really interesting substance called
gun cotton.
And the process to make it is just incredible. You literally start with basic cotton fibers. But then, by soaking them in a potent mix of nitric and sulfuric acid, you chemically transform the cellulose. You pack it with these nitro groups that carry their own oxygen. And just like that, you turn harmless cotton into a powerful self-oxidizing explosive. It is a perfect example of chemistry creating something totally new and powerful out of something totally ordinary.
So let's just take a step back. We've seen how one methodical process, applied through chemistry, has shaped our food, our clothing, and even our global power structures. So what does that tell us about what's coming next?
This quote really just nails it. This isn't just about history. Right now, as we speak, chemists are using that very same scientific method to develop everything from biodegradable plastics to more efficient solar panels to life-saving medicines. That work to make our lives better, it never stops. And that brings us right back to the main idea, the real takeaway here. The scientific method is that hidden engine. It is always running in the background, fueling the discoveries that build and rebuild our world, usually in ways we don't even see unless we really stop and look for them. So, if the methodical application of chemistry gave us all of this, from feeding billions to creating new fabrics to smokeless powder, it leaves us with one last, really exciting question to think about. What will it build next?